My name is Gaurav. I'm a full stack developer working at Geektrust, a bit over 3 years now. Overall, I have more than a decade of experience writing software and working in the software industry overall. So yeah, thanks for joining, guys. What better time to learn something about testing than a midweek Wednesday evening? So let's dive into the session straightforward. So today's session is going to be focused on how you can actually write unit tests for your code. So that's the theme of the session. But we will be talking about a little more than just unit testing. We'll actually discuss or quickly cover one of our previous sessions as well, where Dhanush, who is the CTO of Geektrust, he covered a session where he took a bad piece of code and spent about an hour and a half to convert it to a good code. He went through why the code was bad and why it was good. So we'll be doing a quick recap of that. We'll use that code as a reference. And once we have done that, we'll basically use the same code base to learn how we can basically write unit tests for that code. So we are going to do this exercise using Java as the language, and we'll be making use of IntelliJ IDE as the primary IDE. So let me just share my screen quickly. Okay, I hope everyone is able to see my screen. Please do let me know if it's not visible. Let me hide all of this. Okay. So yeah. So talking about testing, is my screen visible? Can I have some feedback?
Yep, it is.
Okay, cool. So talking about testing of code, right? So testing in itself is a very big branch of software engineering, right? So testing can be done in many different ways. You have unit testing, which we're going to discuss today, but apart from unit testing, there's a lot more. You have system testing, integration testing, and then there is black box, white box, different ways of testing, load testing, stress testing. So all of these testing things that we basically do with the software, they give us a different idea about how our software performs and what can be improved or what is wrong with the software so that we can basically make the software better. So now why we are focused on the unit testing? So unit testing is the only or one of the ways where a developer at his own level can ensure that the software that he's producing is of top-notch quality. There are no bugs, and whatever code that he writes, he is able to document that code as well. So unit testing basically allows you to do a lot of different things. So we'll be discussing all of those things in the session. So starting with, now let's see what is a unit test, right? So now we want to dive into what exactly is a unit test. So when I talk about unit test, let me just hide this. I think it's blocking it. Yeah. So what is a unit test? So unit test is nothing but another piece of code which is written to ensure that the previous piece or the main piece of code works as expected. So basically you're writing some more code to ensure that your code, which was written for a feature or maybe for any particular implementation is working as expected, right? Very simple. So that's what you're going to do with unit tests. So why do we unit test, right? So there are a lot of reasons why you should write unit tests. We will be discussing a few of them. So code ownership. So this is one of the reasons that I personally believe in. So I feel that whatever code you write, you actually own that code, right? So anything you write in any particular software or any particular application, you should own that code and you should ensure that the quality of that code is high. There are no bugs in that code and that the code basically works in a way that it was intended to. So unit test also makes your code easy to debug, right? So if you actually have unit tests written in your application, it makes it very easy for you to identify and fix any bugs that might come. So a lot of times what happens is that you don't really realize what kind of bugs have been introduced in the code when you're actually writing the logic for any particular feature. But when the application is actually put to production, people use it, then a lot of bugs are being unearthed and we then struggle to figure out how to reproduce that bug and fix that. So unit tests actually make that easier, right? Because you can figure out where exactly is the bug in the code. And if you have a unit test for that piece of code, you can try and reproduce that bug using whatever means necessary and fix it then and there. So it makes your life very easy as a developer. It improves your code quality. So again, drawing from the previous point, right? So if you are able to easily fix your bugs, you're able to easily identify your bugs. Eventually, what that does is that it improves your code quality. And once you have an improved code quality, overall, your application also becomes good. The other thing that unit tests also help you is easy documentation. So when I say documentation, I'm not really talking about the documentation that you see on Word documents or maybe conference pages. What documentation this is basically how a developer can ensure what is the code doing, how the developer can understand what is the code intended to do, right? So if you join a new product or maybe a new company or a new team, right, and you are starting to work with a new code base. So many of the times you won't really find end-to-end documentation which will explain to you what exactly is the code intended to do, why is this service there, what is the particular method which is written in the service doing. And it becomes difficult for a new person to basically figure that out when he's working on a particular story. So if you have unit tests that actually can be used by a developer to decipher what is the implementation of the method, why is the method there, what it is trying to do, and if and all he's trying to make any changes to the method, he can confidently do that without worrying about producing any side effects. So if he makes any change, he can for sure ensure that whatever was working before is still working, and whatever he has introduced new is also working. So that's what unit test does for you in documentation, right? So now moving on to how we can actually write unit tests, right? So as I said before, we are going to make use of the code base that we used in the previous clean code session. So I actually have that open with me. Let me open that. But before that, let me give you a brief idea what exactly unit test looks like, right? So if you focus on the left side of the screen, this is a pictorial representation for a real system. So all of the puzzle pieces are different software code that is interacting with each other. And the puzzle piece, which is green in color, is the highlight which you want to test, or which is the class in focus. And the yellow color puzzle pieces, they are basically the dependencies of that class, right? So each class might be interacting with some other classes, maybe a service class or a DAO class or maybe a model or whatever it is. So if you look at it as a big picture, this is what a unit test is. It's actually focusing on a single puzzle piece. And now I want you to focus on the right side. So block the entire system, only focus on the piece that you want to test, ensure that all the dependencies are fulfilled, and with those dependencies, what is the outcome that your class or your method is producing. That's what the function of a unit test is. So this is how we are going to do or write unit test. So let's dive into code straight away. Okay, so I have already prepared this for now. So if you see on my screen, I already have both the codes open. So on the left side of the screen, let me make it larger for you. So this is the code that we started off when we did the previous session. This is the bad code, right? So before we go into the code, I would like to explain to you what problem we are trying to solve here, right? So we are actually working with the family tree problem. So this is one of the old Geektrust problems, which was very initially there. And the problem basically gives the user a family tree, which we can see on the screen right now. And the family tree has King Shan and Queen Anga as the root of the tree. And then there are their children, the children of children, and basically a regular family tree that you can have. Now, what the problem asks the person is basically enable the write a code that will execute two commands. One, the first command being the add child command. So what this command is intended to do is that given a mother's name, a child's name, and the gender of the child, it should add that child to the family tree under the mother. And the second command that we expect the code to execute is the get relationship command, which expects the name of the person and the relationship that we want that person to have. So, or basically we want the relationship that we want to retrieve from the family tree. So this is, these are the two commands, add child and get relationship, that the person has to implement. And then there is an output which is intended for both of these commands. So the add child command will either print it as child addition succeeded. And the second command, get relationship, will basically give you the names of the people who fall under that relationship. So that's the outcome. So this is the entire problem, more or less. But when you we expect the person to basically build the entire family tree in memory and perform all the operations in memory, and the code has to be object oriented, readable, and all those clean code principles that we generally follow. So I'll quickly go through what relationships we ask the person to implement in the problem. So we have define the relationships which are here. So we have paternal uncle, maternal uncle, paternal aunt, sister-in-law, brother-in-law, son, daughter, and siblings. And the definition for those relationships are also given in the problem. So that being the overview of the problem, let's dive into the code. So in the previous session, where we converted the bad code to the good code, we basically took the bad code, which is on the left side of my screen, and we ended up with the good code, which is on the right side of the screen. Now I will basically go through why the code which is on the left side of the screen is bad, right? So let me hide this again once. Okay. So why this code is bad per se? So if you see whatever problem I explained to you in the just right now, right? So that entire problem has been solved by using this entire project. So it only has three classes, mainly the main class, a person class, and a family class. So just assuming that all of the logic would be written in one of these three classes, it seems that the project is overloaded with the lines of code and it might be stuffed with information. So it's not really the ideal software or the ideal code piece that you want to have. Apart from that, if you see, we have a test class. Let's see what's there. So there's nothing inside the test class as of now. The test class is empty. So we don't have any test cases. That's again a red flag. So let's start one by one, right? Let's see what we have inside the files. So going through the main.java file, let's see what we have here. So we have a main class, which basically is initializing the family tree. This is the tree that we saw in the PDF. So it's taking that input, it's creating a family object. It's reading the file which is coming from the input. Based on the input, it will basically execute each line of the file. And then based on the command length, it's taking a decision whether it wants to call the get relationship command or the add member command, which is the add child command. So what is not great about this class is that we can see that there are a lot of hard coding, right? So this particular section where we say that command.length equal to 3, command.length equal to 4, this doesn't give any context, right? You don't know what's the command, what does the length of 3 mean, why is it important, what does the length of 4 mean, why is that important? So there are a lot of things that are left for assumption, which is not great for any code. Overall, the file size is okay. I think there's not much of code, which is fine for a main class as it is intended to be an entry point for the program. So moving on to the next class, let's look at the person class. So taking a first look at the person class, a few things that are not right with this class is that the first thing I can notice is that the associations that the author of this code has created for the father, mother, and the spouse are created as a string, right? So that's not the ideal or the best way of creating associations within an object, because string is just an information that you can use. You cannot really do anything with that string. Now, an ideal alternative for this would have been that we would have used objects here. Since we already identified the person object, we could have added this father as a person object, mother as a person object, and spouse as a person object, so that we can actually make use of the information inside those objects to identify any of the relationship that we might need to solve for. Apart from that, we can see that there are a lot of setter methods. So there are getters and setters methods, which basically the class is breaking encapsulation, right? So when I say it is breaking encapsulation, it is basically allowing someone to edit the state of the object or basically modify the state of the object from outside the class, which should not be allowed, right? So if you try and compare this person with a real life person, so when a person is basically born, or compare it to when you create an object. So let's compare these two states. So a person being born and an object being created can be equal. And once a person is born, a few things about that person are fixed then and there, right? So the father of the person, the mother of the person, the gender of the person, for example, are fixed now. You don't really go ahead and change that in the future abruptly. You don't allow someone coming from outside saying that, no, he's not your father. No, the other person is your father. So those kind of things shouldn't be allowed, right? And whereas when you provide a setter method for such relationships on an object, you're actually allowing that kind of thing to happen. So that's not a good thing to have, which is basically breaking encapsulation. So apart from that, there are not many behavior methods on the class, right? So there is only one behavior method that we have. There is an add child method, which is okay, but there can be a lot more behavior that can be added to the person class, especially considering that this is the main object or the only object that we've identified from the problem. So I feel there can be more behavior. So once we look at the good code, we'll see what we have done and how we have modified this class and how we have made it more object oriented. Let's look at the family class quickly. So in the family class, we see that, okay, so we have a person, king and queen as the root. So this, I think, is representing the family tree that we saw. We have a record map and a spouse record map. Okay, so record map is probably keeping the family tree information. Spouse record, not sure what it's doing, but assuming it's keeping the spouse's information. So we have a bunch of methods here. So we have for create family, get family instance, add member, add relation. So these methods look fine. Okay, add spouse is not the correct or the apt method should that should be there on a family object. So why it's not apt is because when if compare it to real life again, right? So when a person gets married, he gets married to another person. They don't get married to a family. So when you say family dot add spouse, it doesn't really make sense. But when you say person dot add spouse or person dot get married, then that makes sense because you can relate to it with what happens actually in real life. So again, find person is okay. So we have a get relationship method. So another problem here is that we can see there are a lot of hard codes, right? So we can see that magic values are present. So the string is there. Then we have relationships defined as string again. So one problem with using magic numbers is that if you use the same value or same hard coded string at multiple places, you have to, in case you want to update that particular value, you have to update it at every place. So that's cumbersome to do and it takes a lot of time. And if it's a very big project, that will become a source of bugs or issues that might crop up in the solution later. Apart from that, you have to maintain a lot of other things, right? So when you're matching two strings, you have to ensure that the case is same. The string has to be sent in the exact format if there are any special character in the string like we have here. So all of these things can be avoided if we just use a constant or maybe use a enum instead of this. So when we look at the good code, we'll probably see what we have done there. So we have get son, get daughter. This again, the same reason that these methods make more sense on the person class because family might have multiple people who will have sons, similar with the daughter. Siblings, again, family don't have siblings, a person has siblings. Again, so we have a lot of, or basically we can assume that all the relationships that are defined here, or the entire logic of the problem is basically put inside the family class, which is not good to have because now the entire class is doing too much and we don't want the complete responsibility of the entire code to be in one class, right? So other thing is that we have dummy and we have gender as hard coded again. So gender could have been an enum. So, okay, so these are the things that basically make this code bad. So the readability of the code is low because there are like the code has multiple if else loops, there is nesting, there is hard coding, and it's not really maintainable because all of the logic is written in one file. And if you want to update the code or make any change to the logic, you'll have to probably go through a lot of changes that you probably could have avoided. And there are no tests as well, right? So we don't have any test cases. That's again a red flag. So now that we have figured out why the code is bad, let's get rid of this particular code for now. Yeah, just minimize that for now and focus on the good code part, right? So let's see what we have done here. Let's go class by class. So looking at the main class first. So this class, we haven't really done any or much changes, which is fine because main class is anyways intended to be an entry point. So as long as it calls the commands correctly, that should be okay. Looking at the person class now. Okay, so we can see that what we discussed earlier, right? So we have changed the relationship or the associations for the father, mother, and the spouse. We have added them as objects. Now, the advantage of doing this is that we can actually use the behavior methods that we add on that object and identify or use those methods to extract information on those objects. So we'll see when we actually go to the code, how that's beneficial. We have removed the hard codings, I think, and we have added a lot of behavior now. So a lot more behavior than what we had earlier. So earlier we only had a one child method. Now we have a spouse method, as we discussed, a person gets married to another person. So it makes more sense here. Person might have children. So this also makes sense. We have siblings. We can also get siblings based on gender. If you want to find only sisters or brothers, we can also do that. And then there is a equals and hash code. So overall, this class looks a lot better than what we had before, right? So now we have a proper object with proper associations established with all the relations. So now we can call that this particular class is much more object oriented, and it actually satisfied our object modeling check that we actually do on the Geektrust website, right? What we recommend, we have implemented that. So let's look at the family class now. So the family class was the main source of problem, I think, that we had. We had a lot of code in the family class. That was the first issue. So, okay, so now we see that the family class is slightly reduced, or it's reduced a lot, right? It's earlier it was more than 350 lines of code. Now it's less than 150. So a lot of improvement there. Apart from that, we can see that the four state variables have been changed. We have removed the spouse record, I think, which makes sense because a family tree spouse or a regular member of that family will be maintained in the same tree. So we need not have a different tree for the same information. Apart from that, since we already added the information of the spouse on the person, if we need that information, we can get it from the person object as well. So that's one advantage of having the spouse as a person there. Uh, Apart from that, what else do we have? So we see that we have removed the hard codings. We have created constants for this. There's a constants file also we can see here. We have created enums for gender as well. We also have created, yeah. So for relations as well, we have created enum. So now we don't have to worry about matching the case of the input and all of that stuff. We don't have to do that. We can directly use the enum, and this looks a lot clear, right? It's even looking at the class, it makes it look nicer and it's clean, and you can actually go through the code without any issues. So now that apart from these two classes, we see that we have a lot more classes introduced. So we can see that there is a relationship finder introduced, or I relation finder. So this is an interface which expects, given a person, the implementation of this interface should return the relation of the person. So we expect that the finder will implement this method, and given a person, they will return some value, which will be a list of person. So let's look into one of the finders. Let's see maternal aunt finder. Okay. Okay, so what this is doing is basically implementing that method. Given the person, it is figuring out who are the maternal aunts. Okay, so this makes it a lot clear, right? So because earlier we were doing everything in the family class, it was not sure what exactly is the functionality and how we are doing that, but now it is a lot clear. We can see that we have separated out the responsibility for each class. So this is an example of separation of concerns, right? So now anything that has to do with maternal aunts can be done in this method. Similarly, for other relationships, we have individual classes. So the advantage that it provides is basically it makes the code lean. So each of the relationship has only the code which is making sense for that relationship. And it allows you to make easy updates. So if you want to make any changes to the code, you want to update the logic, you want to add logic, or you want to make any other changes, you don't have to depend or basically uh, worry about breaking any other code, because this code is separated out. You can actually do it only in this class and you'll be fine. And the next advantage it will give you is that you can actually easily test this class because it's separate. So now that we have established how this code is better than the previous code, it's a lot more readable. The object orientedness of the code has been improved to a greater extent. And we can say that in all the aspects of clean code, this is a lot better, right? So, okay, let's quickly look at the test cases if we have any. Okay, so earlier we didn't have any test cases. Now we have a person test. So I believe these test cases were added as part of the refactoring to ensure that the code works fine even after refactoring, right? So let's quickly do a quick run of this test and see if the tests are working. So I hope whatever I explained so far had made sense to you guys, and that will be useful when we actually talk about unit testing. Okay, so we have some issues in the code. Okay, so I know why this issue is there. So it's a Gradle related issue since we are using Gradle here. So I'm actually using IntelliJ IDE Community Edition. It's a very good IDE for people who work with Java. Makes life simpler for the developers to a great extent. So I recommend this ID, you guys can use it. So I'm just quickly going to fix this error. I'll go to the build tools, go inside Gradle. So we are actually using Java 1.8 and the Gradle was configured for using Java 16. So that's why the error was popping up. Okay, so I've changed that. Let's quickly run the tests again. So I do see a couple of chat here. Maybe there are questions, I'm not sure, but we'll be answering those questions if you have anything.
I'll take care of it, Gaurav. Thanks.
Yeah. Okay, so we can see that all the test cases are working, which is a great thing. So now let's head and see how we can actually write unit tests, right? So these tests are already present. Let's see how we can actually write these unit tests or how we can go about testing our code. Let me hide this again. So I'll just close all of this. So before we actually write the unit test, there is something that I feel I can do with the code here, right? Before I go about doing the unit testing thing, I see that the project structure is pretty linear here, right? And when you're talking about readable and maintainable code, project structure or good code structure is one of the aspects. So we can actually bundle up classes which we feel should be in a single package. Let's do that quickly. So I think that the class person and the family are the main domain models of the complete problem. So I'll quickly create a package here, call it domain, and I can move the person and the family class here. So this is one benefit of using the IntelliJ ID. I don't have to worry about the imports. As soon as I click on refactor, the ID does the rest for me. It updates all the imports. Apart from that, there are enums and constants that have been created. So let me quickly create one more package. Let's call it constants for now. And I'll move the enums and the constants file inside. So constants and enums are synonymous, right? So we can basically put them in the one package. Apart from that, so the other classes that we introduced, the finders for each relationship, now we are only left with that and the main file. Excuse me. So we can actually bundle this together as well, right? So these are sort of helper or service classes. You can give it any name. You can call it a helpers package or a services package or anything else. For this particular problem, since we are using the naming convention of finders, I'm going to name the package as finders. And I'll put all of the classes that are related to finders inside that package. Click on refactor. Okay. So now my project structure looks a lot better. We have bundled all the classes that seem to be related to each other. And now we can go about how we can test these classes, right? So let's start with the domain class, right? So we already had some tests for the person class. So I'm going to skip it for now. Let's look at the family class straightforward. So what do we have in the family class, right? So if you guys have gone through the Geektrust help docs or any of our material that we have on the website, we generally recommend that all the public methods should be unit tested, right? So the reason for doing that is that when you create an object or whenever you create a class which has public methods are something that interact with the code outside. So anything that is generated or the output given by the public method is what is going to affect the state of the entire application. So the best part you can do is that you can make sure that that method gives the correct information out to the application. And that's where we say that the public method should be tested. And eventually private methods are anyways not accessible, so you cannot do that. So let's look at what's the first public method we have. So we have the get family instance method as the first public method. So let's see how we can test this method. So it's, and before that, let's see what it's doing. So it's expecting an input family of type string array, throws an IO exception. And if the family object is null, it creates a new object and returns me that family object. So it's basically giving me the family object, a way of creating the new object for the family. So let's see how we can write test. So the easiest way of generating a test or writing a test is, I'm again going to use the IDE. I did a right click on the method name, click on generate. Here we have an option to generate test. So this again saves a lot of trouble for me. It selects the testing library on its own. It has given a name because we're testing the family class. The name is come as family test. There's a destination package, com example, Geektrust domain. Now I need to select which method I want to generate test for, since we were talking about the get family instance. Let's go ahead and select that. So I'm going to click OK now. Okay. So what it did is basically generated a family test class and a get is family instance dummy test method, which is empty as of now. So before we write any actual code, I just want to show you guys something that how the ID created a family test and where it is, right? So we can see that it created a domain package under the test folder, which is again the same structure that I had followed in my source folder, right? So that's what we expect, that the source and the test folder should ideally follow the same folder hierarchy, because it helps people to navigate the code easily. So it makes sense. So ID has done the same thing. Since person is also a domain class, I can actually move it inside the domain package here. Okay. So now if we see, we have the exact same hierarchy on our source and our test. So let's go down to the test class. So this is the test that got generated. So what exactly am I going to test here, right? So my test should be, so what I expect here is that the method should return me a family object, and it expects an input of type string. So let's see if we can do that. So I'm going to create a family object, and I'm going, since it's a starting method, I have to access it like this, family.get family instance. Now the expectation here is that it requires a string array of input family, which is of type string array. So I need to give any valid value, which is valid for a string array. So I think null is a valid value here, right? So I can give that value as null. Let's see if, okay, so there is an IO exception which was thrown by the method. So I'll just quickly fix that by adding a throws here. So this is the call that I'm making to the method which I want to test. And the object that it returns to me is family. So I want to see that if I get a family object. So I'll basically assert that whatever object I'm getting should not be null. So I'm going to write an assert here. So this assert is provided again by JUnit and family object. I'll pass it the family object. So this is the very basic test that I have for myself now. Let me try and run this method. So let's see if this method runs or not. Okay, great. So the first test and it failed. So let's see what's the error. So we are having a null pointer exception. And let's go through the stack trace. Let's see where is the exception coming from. So it's coming from create family, family.java38. Let me control click on this. Okay. So it's coming from this line basically. So where is this create family calling? Okay. It's coming in the constructor. Okay. So now if I trace back the error, I can see that when I call the get family instance method, which I provided an input of null, that input, since the family object is null, it will try and create a new family object, and it will pass null to the constructor as well. And the constructor again is initializing a few things here, and then it's calling the create family method, which again is trying to use the input that I had provided to initialize a family tree. So, but the input is null, right? And we haven't handled null here. So I feel that that's the issue. So we didn't know about this issue before we wrote the test, right? So now that we know the issue, let's see how we can fix this, right? So one fix would be I can just say assert it to be null, but that won't really fix our null pointer. So that's not the correct fix. Let's go back to this. So one a quick fix or the ideal fix would be that whatever input I provided, I validate that input first. So I'll just check if the input family is null. I don't initialize the family tree, right? I just return from here. So when I return from here, it's basically going to validate that the input is not null. Or if it's not null, only then it will reach the for loop, and that's going to, or ideally it should fix my issue here. So let's go back to the test. I've added the fix for the test case. Let's see if it works. Okay, great. So our test passes now, right? So that's one of the cases. Now, since I figured out that when I pass null, it throws me an error. So there can be other cases where it might throw me an error. So another case that I can think of is that I can pass it an empty array, right? So I can just initialize an empty string array, and I don't want to pass anything else. Let's call it family1 for now. And let's assert the same thing, assert that whatever I get back is not null. I'll run the test case again. Okay, so it doesn't break when I pass it an empty string here. Now let's, again, the actual case or another case that can be made is that we pass it an actual information or a string which initializes a family tree. Now, so I'm going to copy a bit of code here, right? So this is how we are trying to initialize a family. I'll just copy a few lines here. Go back to my test case. Create an input family variable and initialize it with whatever I copied there. So now I have a string which should initialize the family. I'm passing this string to the family instance method. So the expectation again is that whatever I get back from the get instance method should not be null. So this is my family2 object. Okay, so let's run this. Okay, so it passes, right? So the three cases that I could think of right now, we can pass it a null, an empty string, and an actual valid string, and all of the three cases pass right now. So we are done with our one of the unit tests. But one thing about this unit test is it's not a great unit test, right? So any ideas why it's not a great unit test? So you guys can't answer me, so I'll quickly answer myself. So why it's not a great unit test is because we are actually doing a lot of things in a single unit test. So it's like when we say single responsibility principle for methods and classes, right? Same applies here. So since first we are asserting that the unit test breaks when it's null, second we are asserting that if it's empty, and the third assert says that when it's an actual input. So the better way to do this would be that I break it down into their own unit tests. So let me create a new unit test here. And how can I differentiate, or how can I tell the user that this test is actually doing that? I will give the test a meaningful name. Should create family instance with valid input. So this is the name that I'm going to give to my test. I'll quickly add the exception here. So now this test, same thing I'll be doing for the empty as well. I'll quickly add a new test here and give it a creative name, family instance with empty input. Okay, again, add the error here. So the first test that we had, get family instance, we can actually leave this name be, but I'll try to use the same convention here, and I'll give it a name as should create family instance with null input. Okay, so I've changed the names, I've separated it out. Now let's see if there's any advantage of doing that. Let me run the class tests. Okay, great. So all of the three tests that we wrote individually work fine. Now, if you quickly notice this area, right? So when we change the name of the test and we split it out, now we know that each of the tests is passing and each of the tests is actually doing a separate thing. So the first test is checking for the null input, the second is checking for the empty input, third is checking for a valid input. So let's say if you had hundreds of tests and for some reason, one of the tests failed, by the name of the test, you can figure out why the test would have failed. So what's the probable cause of failure? And you can quickly go and debug that, right? So as we discussed while talking about why you should write unit tests. So this is one of the ways it helps you debug issues, and it will basically help you fix those issues even quicker. So this was one of the methods. Let's see what else should we test. So this was the method that we covered, right? So next method that we have is create family. So this again being a private method, we can leave it be. Let's look at the next method. Okay, so the next method that we have, or the public method that we have, is add member. So let's quickly go through what this method is doing. So the method expects a string mother name, string name. So I assuming that this is the name of the member we are trying to add, and the gender of the member that we're trying to add. So it's trying to use the mother's name to find that person in the tree for a person object. If it's null, it is going to print something on the console and return back, which is fine. If it's not null, then we are basically checking if the gender of the mother is male. If it's male, we again print child addition failed on the console and we return back. And if all of the validations here pass, we basically do the actual operation that we want to do here. So we get the spouse from the mother and we create a new person object using the second constructor on the person, which takes a name of the person, the gender of the person that we passed in the method, the father that we got from here and the mother object that we identified here. So we pass the information, create a new child, put that child object in the record, add a relation to the mother, add a relation to the father, print on the console, child addition succeeded, and then return. Okay, good. So that's what the method is doing. Fairly simple. We are able to understand. But when we want to test this method, right? So what should we test with this method? So one problem with this method is that this method is not really testable. So when I say it's not testable, the reason, okay, let me just quickly drink some water and I'll give you like 10-15 seconds to think of the reason and then I'll tell you about it. Okay, so probably not 15 seconds are not yet over, but so the reason why this method is not testable is because it doesn't really return anything. So it's returning void. And the only output that we're getting from this method is that it prints something on the console. So now someone can actually argue that since it's printing something on the console, we can just check the console value and figure out that if the method ran correctly or it didn't do what it was supposed to do. But that's not the ideal way of testing a software or a method functionality, because that will work if you are doing code live or you're developing a feature. You can run the test, you can quickly check the console, but that will not work when you're actually working in a production environment and your code has to be validated by running all the test cases, for which you will have to ensure that the test case actually validates something. So here, even if you write a test case which calls this method, the test case won't be able to validate anything because the method gives it no feedback. So a better way or maybe a simpler way to understand this would be, if I'm talking to you, I ask you what's your name and you just listen to me and you turn back and go away. I didn't get any feedback. I still don't know if you heard me or if you don't have a name or if you don't want to tell me your name. But if you would have told me your name and then whatever happened after that, then there was some feedback. One information that came to me was that I know your name now. So we can use that information to validate or basically do whatever I want to do. So how we can make this method testable? The simplest way would be to return something. So what can we return here? So we see that in all the three cases, we are actually printing something on the console, right? Which is a string here. So let's return that string instead of printing it. So I'll not remove the prints now. I'll just add what we are returning to the exact position where we are actually printing it. So the first case we returned person not found. The second case we are returning child addition failed. And the third case we'll be returning child addition succeeded. Okay. So now that the method returns a string, we are able to get some feedback from the method and we can actually validate this when we are actually testing the method. So again, quickly, let's try and write a test case for it. Right click, generate, test, same class, same JUnit method, class, method name is add member. Click OK. Okay. So the error says that there is a class already by the name of family test. Do you want to update the class? Yes, I want to update it because it is on the same class. So it generated again a test case for me, which right now has the name of add member. Let's leave it be. So we'll again create a family object here. Family.get, my bad. Family.get instance. Let's initialize it with null because we already fixed this scenario before. We'll not get an exception. This should be a valid case. And now I want to do is family.add member. Okay, so what is the method expecting here? So the method is expecting that you should give me a string mother name, a string name, and a string gender. So a valid value for string could be this as well. So I can do this. Okay, so this doesn't give me an error, right? So let me try and run and just quickly check if anything breaks within the method if I pass empty strings. Okay, so nothing broke in the method, and we can actually go ahead with this approach. So empty strings is a valid input here. And one advantage of not removing the output is now we know that what we can assert for, right? So it is giving me an output that your person should not, person is not found. So what I'll do, I'll add an assert here, and the assert has to be person not found. I'll save this in an output. Okay, so I'm asserting basically that the add member says the person not found if I'm passing empty string. So let's run this case and see if it works. Okay, so this works now, right? So let's add another test case for the same method. Now we'll try and add a different scenario here. Add member with null inputs. Okay, so let's see if we can add a member with null inputs. I'll quickly copy this so that I don't spend time writing it again. I'll add the exceptions here. So basically, I want to pass null here in place of all the values. Gender, can I pass null and gender? Okay, I can pass null and gender as well because it is a string. This ideally should not be person not found, but let's see. I'll leave the assert as is, and if we have to change it, we'll change it. So quickly run the test. Okay, great. It passed, and fortunately, we are again getting the same value. So if we try and add a member with the null inputs, we are not supposed to add it, and which is the correct output. So we again validated one more case, which is the null case. Now let's try and add a member with some valid inputs. Okay. So adding a member with valid inputs, let's change this. Quickly handle the exception. So change the name of the mother to, let's say, mother, person, gender as male. So these are valid values as per the problem and the solution. So if I pass a valid value here, the expected outcome should be child addition succeeded. So I'll quickly do the same thing. I'll do an assert that whenever I pass a valid value, my child addition has to succeed. So quickly run the test. Okay, so right now we are getting person not found. Let's see why it broke. So it is breaking because we are passing the mother name as mother. Okay, so the reason it's breaking is because it's not able to find a mother here. So we'll probably need to initialize a family tree before we can actually add a person, right? So that makes sense. Let's go back to the test quickly. We'll need to initialize the family tree here. So we'll copy this for now. We can't initialize it with null, which is a good thing, I think. So let's initialize it with input family. Now, since we have initialized the tree here, or maybe we don't need to initialize it. I think we forgot something. Let's revert it back. Yeah, so when we actually pass null, we can see that there are a few things which are getting initialized here again, right? So King Shan and Queen Anga were already available. So we can actually make use of those values instead of initializing the tree again. So if I pass Anga here as the mother, I think the test case should pass. Yes. So the test case is passing now. So now that we have written these tests, right? So we have actually tested for add member method, but we only tested for two cases. So we only were able to test for person not found and child addition succeeded. So basically what I'm trying to say is that our code coverage or the test coverage is not covering the entire method or all the scenarios that are possible for outcome from the method. So since we know that there are three possible outcomes, and we only tested for two, our code coverage is around 70% maybe. So we want to test for this particular scenario as well, where the child addition failed is an outcome. So let's see. So when do we get the child addition as failed is when the mother's gender is male. So basically when we try to add a new child to a male member of the family, right? Add member with invalid gender for mother. So let's quickly copy this. I think and select it. Yeah. So instead of Anga, since I know that Shan is also available on the family tree by default, we'll try and add the person on Shan. Let's see if, and I'll need to change this to child addition failed. That's the scenario we're trying to test. Let's quickly run this. Great. So we were able to test all the cases. So what we just did is basically we increased the test coverage for our test scenario, where we ensured that all the ifs and else parts of the code, wherever the code can go based on the inputs that we provide to the method, are covered in the test cases. So now we can be confident that whatever input you provide, our method is going to give you the expected output. So now that we've written a bunch of tests here, so one thing to note is that for almost all the test cases, we are actually initializing a family object here, right? And most of the test cases, we are actually initializing it with null here. So this is something that is repetitive that we've done in the test cases, right? So when we look back, we probably want to avoid the duplication of code. So one thing that we can do here is that we can add a setup method here. So again, click on generate, which is command N is the shortcut. So when you click on that, add a setup method. So what this does is it adds a setup method. This method will be run at the rate before each is the annotation here. So this tells us that it will be run before we run each test case. And what we want to do here is we basically want to create a family object on the class. And we want to initialize that family object by default. So now, since I'm initializing it by default, wherever I have a family instance where I'm using actually the initialization by null, I'm not going to update this test case because this is actually testing for the null input. But for all the other test cases, wherever I'm initializing the family with null, I can actually remove this and it'll automatically use the family object on the class. And by doing this, we've actually made our test cases more lean, and we only have the information in the test case, which is actually relevant to that test case. So we are delegating all the setup information and all the information that might be used or might be required for that test case to run. We can actually put that information in a setup method. So right now it's again only a single line, but when you actually write test cases for more complex methods or more complex scenarios, you will be able to see how a setup method really helps you minimize the code that is written in your test case. So now that we have written the test case for family, I think we have mostly covered the cases that we wanted to do here, right? So let's look at the other methods quickly. So add relation method, again, the problem with this method is that it's not returning anything to me. How we can fix that is we can figure out what it's trying to return. Let's see what it's doing. It's taking a father's name, a mother's name, the name of the person or the relation, and the gender. It's trying to find that father, it's trying to find that mother in the tree. It's creating a new child object, adding those to the records, adding the father and the mother as well to the record. And if the father and mother are not null, it is adding the child relation to that object. So it's doing that. So essentially, we can see that the objective of this method is to create a child, right? So the validation of this method probably should be done by returning a person here. And once everything is done, we should ideally return the child here. So whatever exercise we did for the previous method can actually be again followed for this method and test for this method. So I'll not go cover that because I want you guys to try it out and let's see if you can do it. So apart from that, I think more or less the methods here follow the same pattern where we can actually use what we learned so far and test those methods and write the test cases. So just to quickly summarize, how we can actually write test cases is by thinking, or you can take three default cases to start with, where you pass in an incorrect input, you pass in a valid empty input, and you pass in actual valid input, and ensure that your method is actually working for those things. There can be more edge cases, there can be more scenarios that you can come up with, and you can actually test it based on what you're trying to test. and you can add more tests for it. So the idea behind this is that your test case should work and overall it should function and exactly do what ensure what your method is trying to do. So quickly checking one of the other methods here. So since we introduced finders here, right? So we'll quickly check if we can test one of the finders as well, because it's a different implementation. So let's see how we can write a test case for a finder. Again, I will probably go and do one thing is that I'll try and generate the test by using the ID. So again, it does the manual job for me. It selects the library, creates a class, and I need to select what I want to test. Okay. So, okay, so here we see that we got the method which was generated here for us. And apart from that method, we also have a tear down method which was generated. So what is a tear down method? So before we talk about this, let's quickly see what got generated here. So we see that the ID again generated the package for us by default. And inside the package, it generated the test class. So now coming back, so what is a tear down method, right? So as we learned in the previous test case, all the setup information that we did, right? We had a method called setup, which had an annotation got before each. And this method was being used to set up anything that was required for a test case to run. So now just thinking logically, what could a tear down mean? Let's say you set up something which was uh, heavy on the memory, or maybe you set up some database connections or you added some information to the database which was supposed to be validated by the test case. Now once that is done, you don't really want that information to remain in the database and pollute the other data that is present there. So what a tear down method can help you with is cleanup. So as it says, it is being called after each test case. So anything that you want to set up for a test case, you can add it to the before each method, and anything that you want to clean up after the test case is validated and run, you can add it to the tear down method. So as of now, we don't see a case where we can use it. So I'll probably remove it now, and let's focus on what we want to test here, right? So let's see what's the maternal aunt finder method doing. So what it's doing is it's basically taking a person object and it's figuring out if that person has any maternal aunts, and it's returning the list of that person, right? So let's quickly create a finder. So we are going to create a finder here by using the new method. Okay. So now I have a finder. What I need to do is I need to call finder dot find relatives. So what this is going to return to me is a list of person object. Since we know it's going to be maternal aunts, we'll name it as such. It's asking me to import this. I'll import the class. It's asking me to import this as well. I'll import the class again. Okay, so it expects me to pass it an input of person type, right? So I can actually pass null because an object can be null. So now what should I expect? I should expect the first thing, again, I should expect that the output should not be null for me. Same thing that we did in the previous test case. We are trying to see if the output or the outcome of the method is not null, right? Because we don't want to see more null pointer exceptions which come up. So let's quickly check that. Okay, so now the test case is without any errors and we can try and run this. Let us see what happens. Okay, great. So we are in luck today. We are finding null pointer exceptions in most of the methods that we're testing, which is a good thing for us. So we have a null pointer exception and it says that it's being found in maternal aunt finder Java 13. So let's quickly go inside and see what's on line number 13. Okay, so it says the null pointer is coming from this. What could it be? Because we are passing the person object as null and it's trying to access a method on the person object, it's giving me a null pointer exception. How can I fix this? I can quickly add a check. So I can just check if the person equals to null, return. So I can actually return null here, but I don't want to return null because since we are actually fixing a null pointer exception here, and if we return null, there is a possibility that whoever is consuming that method might not be doing a null check. And that could create a case where they will face a null pointer because of the output they got from a method, right? And since we are the owners of this method, we don't want that to happen and someone come back to us saying you created a null pointer. So it's better we return an empty list, because essentially if there is an empty list, we know there are no aunts. So let's see if this fixes it for us. Okay, great. So even if I pass a person as null now in the find relatives, I'm sure that I will get something which is not null. Now, another assertion that I can add to this is basically, since I know that the object is not null, again, I want to ensure that, yeah, again, I want to ensure that there is no value inside that list as well, right? So I can say that the size of the list should be 0. So this is one assertion that I can do here, because I know that there should not be any value. So let me add that assertion and run it again. Okay, great. So this again works for us. We can give the method a meaningful name. Should return maternal aunts for null input, because we're checking for null input. Let's again do the same thing. Let's try and should return maternal aunts for valid person object. Okay, so I'll just quickly copy this, paste it here. Now, instead of passing null here, what I can do is I can pass a minimum value that satisfies this condition. I can actually create a new person object, and inside that person object, I can give it a name and a gender. So gender is an enum, so I'll pass it as a gender.male enum. So this is the minimum that I can pass for it to be a valid person object. So this will give me a new person object. I'll pass it to the find relatives method. And again, the assertions will here remain the same, because we are essentially trying to say that we didn't add any aunts to the family tree. We didn't initialize anything. So the outcome should also be null or empty list here. So let me run this. Okay, again. So we found another null pointer exception, which here is at line number 17. Okay, so we see at line number 17 again. So this is the line that we fixed before, right? And we are again seeing a null pointer exception here. So I think one thing that I can talk about this is that, so here if you see this pattern, right, we call this as the law of Demeter, where we ask people to avoid using this pattern because of this very reason. So we just fixed the person to be null, and now the mother is null. And since the mother is null, we are trying to access something on that object. It is giving me a null pointer again. So it's like an endless trap. So the more number of dots you add, the more number of chances you'll have to end up with a null pointer exception. So quickly fixing this, let's see what we can do. We can do is that let's create a mother object. Person dot get mother, or instead of this, I can just type if person dot get mother equals to null. Again, I'll just return empty list. Okay, so this should fix for my null exception here. Let's see if I fix that. Yes, so we fixed our null exception here. So we are good when we are actually passing a minimal person object here. So now to actually do the main thing where we want to pass an actual family person object, which has some details, as in he will have the details of the father, the mother, and some details within father and mother, because we are looking at maternal aunts, which by definition are mothers, sisters, right? So mother sisters mean the mothers should have siblings. So now if you look at the problem that we are looking at here, we now realize that there is an advantage of actually adding this object as a person, right? Because the mother will have information about uh, its own family. Since the person has like father and mother, mother will also have a father, and that father will actually have children, which will have the information about the mother's sister if there are any. So let's go back to the test case. Should we'll give it a meaningful name again. Should return maternal aunts for a valid person object with family. So you guys can come up with better names here. I'm just giving names, whatever is coming to my mind as of now. But the idea behind this is that we want to give the context to whoever is looking at the test cases. So again, so before I write the information in this test case, we see that we are actually initializing some information repetitively in the case. So we'll quickly add a setup method again here. Create a method I relation finder of finder, initialize that finder with the, so basically I'm copying this and I'll remove these lines from your test cases. So just, so whatever I'm doing, I'm just refactoring my code. I'm revisiting the code, checking if there is any duplication and just removing whatever is duplicate and making it leaner and cleaner and all the good things that we say about the code. So there's a typo here. Okay. So now what we want to essentially do here is we want to see that, so I'll just quickly type what we are trying to do. So we have a person should have a mother and the mother should have sisters, which is basically the maternal aunts. So this is what we are trying to find here. So to achieve this, basically we'll have to create some structure before we can actually call these methods to test. So I'll go ahead and create this. So I believe we'll need information about the father of the mother, which will eventually be the grandfather or the grandmother of the person in question here. So I'll create a grandfather object, which is again a person itself. New person, I'll give it a name grandfather, and he's going to be male. So I don't need additional information on grandfather because we are not looking for anything beyond grandfather. We are looking for information below grandfather. So just to complete the tree here, there should be a grandmother as well. So grandmother would be female. And we have to marry them, right? And so this is where the behavior methods are very useful. So this simple operation basically establishes a relationship between these two objects. So that's why we insist on having behavior methods, which is also much more readable than actually doing family.add spouse with grandfather and grandmother. Quickly, we'll add the children here, or children as in the mother here. So name is mother, female. So now since we are trying to add mother here, mother will have grandfather and grandmother, or basically the father and the mother for the mother will be these objects. So I'm going to pass the father as grandfather object and the mother as a grandmother object. So I hope this is making sense. We actually had two constructors on the person class. So one was which only required the name and the gender of the person, and the one which had the father and mother as optional that you can provide it. So I'm making use of that constructor here. Again, I'll also add the father. Male. And I don't really need to add the father and mother here, right? Because the grandfather and grandmother are for this person. So father and mother can, father can actually be created without the information of the of his parents. Probably we will not need that because we are looking for the mother side information. So we'll marry them. Now quickly create a child here, new person, child, male, father, mother. Okay. So now we have a child object here. So we had to do all of this preparation to reach this point because the implementation that we are trying to test expects the person object, which is the child object here, to have all this information on it. So when we create this child object here, this will have all this information and we should be able to find a maternal aunt from this information. So let's see. Now we are actually going to do this again. I'll copy this. I'll paste it here. So instead of passing new person here, I'll pass the child object that we created. So let's see, let's do a dry run. If we did everything same, we created a grandfather, a grandmother, grandfather and grandmother are married. We created a mother, a father, father and mother are married. Mother has grandfather and grandmother as. So I think one thing that we are missing here is that we haven't added an aunt. So the mother needs a sister. So let's create aunt quickly. We'll add the same parents for the aunt because the relationship that has to be between the mother and the aunt is for sisters. So this should do that for us. Uh, okay, let's see. So now since we have added the aunt with the father and mother, I'm assuming that the relationship would have been established. We are not using this object. That's why it's a little blurred. We have added the person and we are passing that person here. Let's see if this returns us the expected output. Okay, the test case passed. Okay, so let's see. So we didn't actually update the asserts here. So that's my fault here. The expectation here should be, we want the size of the metal arts to be 1. So now ideally the test case failed because it returned 0. Let me run it again. Okay, so the assertion failed. This is coming from here. It says expected is 1, but the actual value is 0. But it shouldn't be 0, right? Because we did everything correctly here. Let's see why it is breaking. We'll quickly add a debug point here. You can actually use IntelliJ ID's debugger here and click on this, click on debug. It will break on the debug point. Hopefully, yeah. So it stopped on the debug point. Let's go inside. We'll step into the method. Okay, we are inside the find relatives method. Let's see what's happening. So we have a person here, nothing wrong here. Person is not null. Person dot mother is not null. Person dot grandfather is also not null. So we have a grandfather object as well. Now let's see what is wrong. Okay. So if you see here, the size of the children here is 0. And why is that 0? Okay, so let's see. So basically, this is the reason why our test case is failing, or this is the bug that we figured out using the test case. So let's run it through. So the way we are actually adding the relationship is via the person constructor. When we actually, so we haven't got add child here. Is it doing? Okay, so we haven't actually done add child here, right? So we have to do an add child here as well, so that the father and the mother object actually has the information of the children. So since we didn't call this method, it's failing for us. So our setup is basically incomplete as of now. So what we need to do here is that we need to add grandfather dot add child mother grandfather dot add child aunt. So now what this does is basically adds both these mother and aunt as children for the grandfather. Now ideally we should have the children on the father object, but ideally it should be added via the grandmother, right? So let's add it via the mother. Okay, so let's see what happens now. Okay, so it is failing again. So now that we added add child to the mother, let's see what's the add child method doing here. So the add child method is basically adding the child to children, right? So it's not really updating anything else. So ideally, a child to the mother is also a child to the father as well, right? So probably the spouse should also have been updated here. So we can actually make that change here. What we can do is that once the child is added, we can check if this dot spouse is not equal to null. We can do this dot spouse dot add child. So this makes sense, right? Because both of them will have the same child. So the information on the objects should be in parity, like they should have the same information for children at least. So this is again, while we are testing it, we are able to figure out that these are the shortcomings of the code and we are able to fix them while we are writing unit tests. Whereas someone who wrote this code actually, he didn't have any tests, so he might not have thought of this scenario, right? Because it's not really something that might come up eventually. And once you're actually testing it, you are able to unearth that scenario and able to fix for it. So let's see if this runs for us. Okay. Stack Overflow. Okay, I think I did something wrong here. It's saying that there is an endless loop here. Mm, So let's look at the implementation again. So I think what we did here might not be the correct way of fixing it. We'll just revert this change again. Let's see, go back to this test case. Find relatives. The implementation we're looking at is maternal aunts. Okay, so maybe the way of doing this could be, we can actually get the value here from the mother. That could be one change. So this is one possible fix, right? Because what we are trying to do here is that we are trying to fix the test case for this particular method. We are not trying to change the other code. So that's the point of writing a unit test. So we'll probably making the wrong change earlier. We'll change this here, get the children from the mother. If the children are there, and then the same logic continues. Let's see if that fixes it for us. Okay, expected was 1, but the actual was 2. Okay, so why we are getting 2 is that because we have added 2 children here, mother and the aunt, whereas when we are talking about sister, we should only get 1 value. So this is a very minor bug, I think, which should be done here. Okay, I think we are already doing it. So then why are we? Okay, let's go back to the test case. Aunt and the mother is female. Okay, let me revert a bit of things, right? So father and the mother is here, aunt is here, the child is being added to the mother, pointed to the child. Oh, okay. I think we didn't add the child to the mother as well, right? Something is. So I think that was missing in the setup. This should ideally be okay. Let's see. Okay, so we are still getting it as 2. Let's debug it once more. So if you guys have any ideas while looking at the code, what could be breaking, feel free to share it in the chat and we can check that as well. So let's see what we have here, right? So we have grandmother, children as size is 2. And go inside this method. Person is not null. Mother is not null. Grandmother is not null. Grandmother dot children is of size 2. Okay. Both are. Okay. So the issue here is that we are actually checking for the gender as male, right? But we are actually trying to find maternal aunts. Oh, no, but I think that's correct. Okay, let me. So right now this child was the mother, which got added here. So the mother got added here. Ideally, the mother should not be added here because mother is not the sister. So we have to add a check here to basically skip the mother as well. So what we're doing here is child person dot get mother, I think, right? Because we are trying to skip on the mother here. So this ideally should be skipped because we don't want to add the mother here. So let's quickly rerun the test. Okay, cool. So this is what fixed the test. So that was time consuming and a bit flexing. So now we know that why unit tests are important, right? Because something which is a very minor issue here can actually create a lot of problems for a big application. So now look, now we have written considerable amount of tests here, right? So earlier we had 0 tests. So ideally the test coverage was 0. Now, how can we actually go ahead and check what is the test coverage of our solution here? Again, I'm going to use the IDE's help here and I'll probably I'll use this option here, which says run tests in the package with coverage. So let me do that. Let's see what's the coverage for us right now. Okay, so good thing is that all of the test cases that we wrote are passing, which is a good achievement. And how do I hide this? Okay. Okay, so what this is telling me is that the class coverage is 30%, the methods coverage is 53%, the line coverage is 39%. So I think this is what we are looking at the overall coverage. So since we have not written the methods or tests for a lot of methods here, you can see individual coverages also is given by your ID here. So we have covered the domain, person class is 81% covered, family class is 50% covered, constants is gender is 100% covered. So you can actually increase the coverage of the code by adding tests for most of the code that you have written. And once you have that in place, your coverage will go up. So ideally, we recommend that anything which has a coverage of more than 80% is a good amount of coverage to have with your code. But if you can actually achieve 100%, which is very good, but there might always be scenarios which you might not be able to cover in unit tests. But it's always a relief that you have some unit tests which have a good amount of coverage and you can actually avoid issues, the kind of issues that we just faced here while writing the unit test. I think it gives you a fair idea of why unit tests are important because these issues might not be very evident when you're writing the code, but when you're actually testing the code, your mindset is different. You're trying to figure out what will break the code, and that's where you identify the bugs. So I think we have taken a good amount of examples, how you can actually go about writing the test cases and how you can do testing for different types of code, what you should look for. So if you use these basic principles, you'll be able to write, or you should be able to write test cases for any code in any language. And probably I think that should help you in the long run as well. So just as an ending note, so I'm not going to cover all the classes here because essentially the approach will be similar. It's just an effort that we have to put in and write the test cases for that. But the overall approach is similar to write test cases for it. And I'll probably leave these things for you to figure out on your own and maybe gain some experience by writing that. So once you have a good amount of unit tests and good amount of coverage, I think you'll feel that the importance of writing unit tests is even more there. So I think I'll end my talk here. If you guys have any questions, we can probably answer that. I'll hand it over to Dennis now.
Thank you, Gaurav. Thank you very much.
Hey,
As Gaurav said, if you have any queries, we'll open it up to the chat. You guys can ask any questions that you have about the session.